Hello everyone, welcome back to my YouTube channel. I am your Deepak Prasad, studying at Sri Venkateswara College of Engineering. So, I study in Devu class, SEM 2. So today's subject is going to be Introduction to Civil Engineering, and the subject code is BESCK204A. And today's topic is about centroid and the problem, and we are going to discuss about a problem based on centroid. In this introduction part, we are going to see about what a centroid is. So, what is a centroid? A centroid is a geometric center or average position of all points within a shape or object, regardless of its density or mass distribution. It is a fundamental concept in mathematics, engineering, and physics as well. In two dimensions, like a triangle, it's where all medians intersect. In three dimensions, such as a solid object, it's where all three coordinate axes intersect. The centroid represents the balance point of an object, where it could be balanced perfectly on a pivot without any rotation. Understanding the centroid is essential for analyzing structural stability, fluid dynamics, computer graphics, and various other applications across different fields of science and engineering. Coming to the main part of this video, which is nothing but how problems are going to be solved. Okay, so here we are going to discuss about the equations which are required to solve a problem based on a centroid. If you see the picture over the right side, the main heading is centroids of some important geometrical figures. Here we are going to see how we are going to find centroids of some geometrical figures. Okay, so in this picture we have the first shape to be a rectangle. The equations are same for square as well. So we have given it in a bracket, same for square. Okay, so while finding a centroid, first thing we do after we know the shape is we find the area of that shape. Alright, so for a rectangle we know the formula is b into d. Okay, breadth into actually it's height, but for height instead of h we have taken d over here. Alright, after finding the area we find the x bar. So the x bar is nothing but centroidal distance from x axis. So the formula of x bar for a rectangle is given by b by 2, which is nothing but breadth by 2. Alright, then after the x bar we are going to find the y bar. Y bar is also nothing but centroidal distance from y axis. The formula to find the centroidal distance from y axis for a rectangle is d by 2. Then after rectangle comes triangle. Same procedure for all the geometrical figures. For triangle, we find the area. Area is nothing but half into base into height, which is nothing but half into b into h. Here we have taken h as d. After finding the area, we next move to the centroidal distance from x-axis, which is nothing but x bar. And the formula is same as the rectangle, which is nothing but b by 2. Then, after finding the x bar, we go to the y bar, centroidal distance from the y-axis. And the formula to find the centroidal distance from y-axis in a triangle is 1 by 3 into d. Alright, you can see the formulas over here, it's on your screen. Then after triangle we are going to see about right angle triangle. So for a right angle triangle, first we find the area. Formula is same as the triangle, which is nothing but half into b into d. Alright, then finding the x bar, which is nothing but the centroidal distance from x axis. Its formula is given by 1 by 3 into b. Then finding the y bar, which is centroidal distance from y axis, it is 1 by 3 into d, which is same as the x bar. So these were the equations for right angle triangles to find the centroid of the right angle triangles. After right angle triangles, it is the circle. So for circle, as such, we also find the area. The area of the circle is given by pi r square, which we know. Then after finding the area, we find the centroidal distance from x-axis, which is given by x bar is equal to r. So here you see is a problem for today. This is a problem for today, and the figure, and we can see the figure given over here. This is the figure given. So now let's start solving this problem. The first thing which we do after we get a problem is we make 6 columns. All right, 6 columns, each one containing values like component, area, x, y, ax, and ay. All right. After making 6 columns, we go to the figure. So first, in the figure, if we check if the image is symmetrical or not. So in this figure we can see that there is a symmetrical part over here. See, if we fold in the center, the both the side images overlap, so it is symmetrical. So we found out it's symmetrical. Second step is nothing but we divide the figure into parts. So we have divided the figure over here. So we get a semicircle. We get a semicircle over here, and the image formed below will be a rectangle. All right, but inside the rectangle we also have another circle. These are our figures which we found out. All right. Next, the thing which we do is nothing but we number the figures. So they have numbered over here. They have given rectangle as number 1, semicircle as number 2, and the circle inside to be number 3. All right. Now we take the first figure. So the first figure which we have considered is rectangle. So rectangle, first thing we do is finding the area of the figure. If you see the figure, area of the rectangle is given by breadth into height. Okay, so the height of the rectangle given here is 500 millimeter. 500 millimeter is nothing but height. So here height is nothing but d, which we are going to take. So d is nothing but 500. B into d. So we have found d. B is nothing but the breadth. So the breadth is they have given over here, that is 400 millimeter. So if we multiply both of them, 400 into 500, we get the value 2 lakh. All right. Now we found the area. After that we have to find the x bar. X bar is nothing but the centroidal component of x axis. So the formula for this is nothing but b by 2. We found out the breadth value of the rectangle, which is 400. We divided by 2. So we get the answer 200. Alright. Now after finding the x bar, we go to the y bar. Y bar is nothing but the centroidal distance from the y axis. So the formula for to find the centroidal distance from y axis for a rectangle, which we saw in the previous slide, is nothing but d by 2. Okay, so we find the d is nothing but 500. 500 by 2, which gives 250. After finding the x bar and y values, multiply x bar with area, we get ax value, and multiply y bar with area, you get the y bar value. All right, when we multiply 2 lakh into 200, we get about 40 lakhs or something. Then we should multiply y bar value with the area. So 250 into 2 lakh, we get this value. This is only for rectangle. So now doing for other components as well. The second component which we have marked is nothing but a semicircle. We have marked it as semicircle, so we write the component name as to be a semicircle. We know the formula to find the area of the semicircle, which is nothing but pi r square by 2. Here we can see the radius of the semicircle to be 200 millimeter. We know the r value, which is it is nothing but 200 millimeter. Okay, now using the formula pi into r square. So r square is nothing but 200 square divided by 2. So when we do this in the calculator, we get this value. Alright, so we found the area of the semicircle. After finding the area, our next step is nothing but to find the x bar. X bar for semicircle is nothing but d by 2. So now we know that the radius of the semicircle is 200. D by 2, d is nothing but diameter. So if radius is 200, diameter should be 400, right? So we take d by 2, which is nothing but 400 by 2. Alright, when we do 400 by 2, we get the value 200. So this is our x bar value. Now coming to the next part, which is nothing but finding the value of y bar, centroidal distance from the y axis. Okay, since we are taking this as the y axis and this is the x axis, we have to count from the x axis to the upper side. Alright, so for y axis, for y-axis, so this is the semicircle, right? So the diameters or radiuses which are below the semicircle have to be counted as well. So there is a the diameter for the rectangle should also be counted. The diameter of the rectangle is nothing but 500. So the equation becomes 500 plus 4 into 200 by 35. The equation to find the y-axis, centroidal distance from y-axis for a semicircle is nothing but 4r by 3 pi. We saw it in the previous slide. Okay, so 4, we know the r value. 4 into r is 200 divided by 3 into pi. When we do this in the semi calculator, we get this value. All right, then multiply the x values with the area and the y bar values with the area, you get these two values. All right, now coming to the next figure. Next figure we have taken is nothing but a circle. All right, now the third figure becomes circle. You know the formula to find the area of the circle: pi r square, pi into r. Now they have given the diameter of the circle, which is nothing but 50 mm. If the diameter is 50 mm, radius becomes 50 by 2, which is equal to 25. Pi r square, which is nothing but pi into 25 square. So we get the value. Alright, now again find the x value. The same logic applies. The same logic applies which was in the semicircle to the circle as well. Here the diameter given is 150 mm. Here the circle is over here. We have to add the diameter given over here as well. Alright, so we get 150 plus 50 by 2. When we do this in the calculator, we get 175 as the answer. Next, with respect to y bar, if we do here, in the question only they are given with respect to y bar, the value with respect to y bar, which is nothing but 200. All right, now multiply with the x bar with area and y bar with area, you get the ax and ay values. All right, now add all these area values, you will get the summation of area. Add all the ax and ay values, you will get the summation of ax and ay. Coming to the final part, which is nothing but substitution in the equations. Here the final centroidal equation for x-axis is given by summation of ax by summation of a. So here the summation of ax which we have got is this, okay, divided by summation of a. Summation of a is this. We divide both and we find the centroidal distance. Alright, same to the y bar, summation of ay by summation of a. Summation of ay, we have got this value. Summation of a is this value. Divide them both and you will get this. Alright, so this is nothing but the process of finding the centroidal distance of a given figure. Thank you everyone. Hope you have liked this video. Please like this video and hope you have understood this video as well. Please like it as it carries marks. Thank you everyone. Bye. Take care.